Hello, my name is Rishi. Today I'll be solving Deep ML problem number 44. The problem is Leaky ReLU activation function. Our task is to write a Python function, Leaky ReLU, that implements the Leaky rectified linear unit activation function. The function should take a float z as input and an optional float alpha with the default value of 0.01 as the slope for negative inputs. The function should return the value after applying the Leaky ReLU function. I'll be doing this in PyTorch. I'll also include a bit at the end where I do this in NumPy. Okay, so let's get started. First things first, the way Leaky ReLU operates is it attempts to solve the issue with normal ReLU, causing dead neurons that can't get gradient updates because all of the gradients get set to 0 because normal ReLU sets any negative number to 0. So Leaky ReLU solved this by applying a float or applying a slope to any negative value. In this case, our slope is 0.01. And it's only to negative values and to 0 that we apply the slope. So our implementation is just a big if question, because if the z is less than 0 or less than equal to 0, then we apply the slope to z and return that. If z is greater than 0, we just return z. So pretty simply put, we can say if z.item is less than equal to 0, then return torch.tensor, because we have to return a torch.tensor by looking at the return type here. Torch.tensor z.item times alpha. And I'm going to set dtype to torch.float because in these examples, the dtype is also torch.float for these two outputs. And it doesn't seem like it's dynamically changing the dtype, so yeah. Okay. And then if that's not true, if z is positive, then just return z. This should work. Okay, and that passes all the test cases. As always, that code is in the GitHub in the description. We can implement the exact same thing in NumPy, by the way. So if z less than equals 0, return z times alpha. Sorry, I have caps lock. Z times alpha, and then return z. And that should work as well, hopefully. Okay, and it passes all the test cases as well. So yeah, that is the Leaky ReLU activation function. Thank you for watching, and yeah, code is in the description below. Thanks.